For this first problem here, we have one set of 10 participants that were measured under two different conditions. So this is going to be a t-test for correlated samples. With the information given, we know the null hypothesis says that there is no difference in pain tolerance between the two conditions, and the research hypothesis says that there is a difference in pain tolerance between the two conditions. Next, we find the critical value. It's a two-tail test with an alpha of 5. Degree of freedom is going to be 10 minus 1. We have 10 participants, so that's 9. And our critical value then is negative and positive 2.262. Now let's write down the formulas that we're going to need. This is the formula for the correlated samples. Now we can start with the calculation so we can plug it in. First we look for the differences, and then for the differences squared. Before that, let me write all the formulas down. So if we look for the difference first, 94 minus 59 is 35. 70 minus 61 is 9, and so on. Okay, my writing, again, not that nice. This is very hard to write on this. But the sum of D is going to be 140. Then we have to square each of those values. So the first one, 35 squared, is 1,225. The next one is 81, and so on. And the sum of D squared is going to be 3,112. Now you plug those values. D squared, the sum of D squared, that's this one right here, and then the sum of D is 140, goes in here, then you square it. N we know is 10. And then you solve for the sum of square first, then you can solve for the variance. Once you solve for the variance, you can then plug this in this formula for the standard error, and then you can solve for T. I'm going to do that on the next page now. So the sum of squares is 1,152. The variance is the sum of square over n minus 1, 128. Now we can solve for the estimated standard error. That's 3.578. And now we can finally solve for T. Let's get the mean, because we didn't do that yet. So that's 14. Now it's just 14. Remember, this again is based on the null hypothesis, so this is going to be 0 divided by 3.578. And we get a t-value of 3.913. Our critical value that we determined was 2.262, so ours is larger, so we can reject the null hypothesis. We want to continue with Cohen's d to see the effect size. Remember, Cohen's d is the mean difference over the standard deviation. So that's just 14 over 11.31. So we got this from here, right? Remember that the standard deviation is just the square root of the variance. So it's a square root of 128. That's how I came up with that. And then Cohen's d is 1.24. So that is a strong effect. We want to do r squared also. Remember, that is just t squared over t squared plus df. And that is going to be 0.630. So it's just our t value of 3.913 squared over the same value squared plus a degree of freedom, which was 9. Our final sentence then is pain tolerance of participants when they use swear words was significantly greater than when they use neutral words.